Hello, everybody. It's a new chapter titled Capacitors. It's chapter 4. A capacitor is a device in which electrostatic potential energy is stored in it. The electric energy stored in a capacitor is aimed to be used when needed temporarily, يعني for a short period of time, until a permanent electric power source is been supplied. يعني صبايا وشباب عم نحكي على device, electric device in which we're able to store energy in it. أكيد ليش we store it؟ لأن when we need it we're going to use it, okay? بس هيدا الستورج بينحفظ لما بيستنفد يعني وبياخد و in a short period of time it decays or it goes, okay? That's why we use it just until we find alternative power supply, okay? In its formation, the capacitor, it's very simple in its formation. You can notice that any conductor of any shape and another conductor of any shape or the same shape, if they are separated or isolated from each other by an insulating material, these three elements, يعني two conductors والinsulator بيناتهم, they form the capacitor. Okay? فإذا any two conductors that are electrically isolated from each other by an insulating material, or okay, that can be هذه الانسوليتر يا اما air or vacuum. ساعتها ما بنحط شيء هيك من ارجي كوندكتور وكوندكتور ومسافه بيناتهم، هذا يعني they are at a distance from each other. اوكي، والاير or vacuum it's an insulating material حكما عم نقول it's characterized by epsilon r حكينا عنها قبل هلا اللي هي relative permittivity. اوكي، it's فإذا the insulating material is air or vacuum or any other insulating material which then is called dielectric. With dielectric, it has an epsilon r which is greater than 1. An epsilon r for an insulating material, air or vacuum. Okay. Other than insulating material, air or vacuum, still it's an insulating material, but ساعتها we call it a dielectric, and it's characterized by epsilon r أكبر من 1. نحن in our course we will be assuming only capacitors that are filled with insulating material which is air or vacuum. Okay, يعني empty vacuum. Okay, now another topic here, we're saying that there is an energy stored in a capacitor. طيب how does this happen? نعرف نحن any conductor or any other material in nature it's neutral. okay, بهالكيس إذا أنا عندي الكوندكتورز اللي موجودين و they are separated by an insulating material، هون ما حاطة شيء معناتها شو معناتها it's air or vacuum. okay. طيب if you have such a conductor والconductor as usual is neutral، فإذا هون بيكونوا هدول uncharged. لما they are uncharged there will be no energy stored in the capacitor. Okay, فإذا when the conductors of the capacitors are neutral يعني uncharged implies no energy is stored. إمتى بيكون عندنا energy storage؟ إذا كانوا هالconductors charged equally بس oppositely. يعني إذا مثلا حطيت هون Q1 هون لازم يكون في minus Q1. وشو بقول؟ الكاباسيتور is charged by Q1. أو مثلا حطيت Q star هون، يعني an amount of Q star, positive Q star. Here there must be negative Q star. And I would say that the capacitor is charged by Q star. Okay, only then if يعني conductors are charged equally but oppositely there will be energy stored. Okay, وحكما لما بدي احكي عن الانرجي ستورد وانا قلت بس لما تشارجد بيكون في عندي انرجي ستورد، فاذا obviously there will be an expression which is dependent على Q and it tells about the energy stored. Okay, فاذا if conductors of capacitors are charged equally but oppositely using an external agent connected across them such as a battery, then energy will be stored in the capacitor. Okay, حكما أنا عندي الconductor neutral. How do I charge it? I should have an agent. Somebody did something or something did a job in charging something. How does it happen? By connecting مثلا هيدا الكاباسيتور okay, by connecting it to a battery. Let's say هيدا بطارية. Okay, I connected it between the two conductors. طيب هيدا it's positively charged. هيدا معنى الباتري إلى polarity إلى positive وإلى negative. البوزيتيف هيدا it's neutral. It has electrons and protons. It has positive and negative charges equal to each other. Okay, طيب هيدا البوزيتيف polarity is going to attract to it electrons. فإذا electrons will be flowing this way. Okay, electrons will be flowing this way. لما I shifted some of the electrons here, I removed them. Okay, so what will remain here will be this will have more positive charges than negative. يعني in other words, it will be charged what? Positively. Okay, positively. So this is charged by plus Q. طيب where in this system of conductors والباتري okay, what happens لهدول الالكترونز اللي انشالوا؟ they go through this wire and the battery and accumulate here. فإذا they continue their path and come this way هدول الالكترونز. So at the end what happens here? There will be negative charge okay, equal in amount which is Q to that one here. Okay, only then if this capacitor is charged okay, then there will be energy stored. وحكما حنلاقي expression that relates the energy stored مع ال Q. Okay, so what we're going to say okay here بعد ما قلنا انه it's stored by a battery agent okay, of course the energy will be expressed in terms of the charge. وكمان لازم نحط بذهننا شغله كمان بما انه عم نحكي على electrostatic energy stored okay, it is noticed that in any region where there is an electric field there will be energy stored. وحكما لازم يكون في expression that relates the energy stored to the electric field. اوكي، فاذا انا عندي الكاباسيتور لما اتس تشارجد، اذا انا حطيت فولت ميتر هون there will be voltage اوكي potential difference. وحكما صبايا وشباب كلنا بنعرف if I have charged element وهيدا charged element due to the charges there will be electric field created. You will notice that here مثلا in this capacitor اللي هون positively charged هون negatively charged there will be electric field that is directed من ال positive للنيجاتيف okay established between the two conductors. هيدا الالكتريك فيلد. وهلا عم نقول كل ما يكون عندي region في بقلبها electric field there will be energy stored. واكيد هون there is a built أو it is constructed an electric field region because we charged the capacitor. فحكما شو حيكون في energy stored وحنحكي عنها بعدين ونعطي الexpression when we come to that part. Okay, now ladies and gentlemen, any capacitor is characterized by its capacitance. فإذا under the title capacitance, any capacitor is described or characterized by its capacitance, which has the symbol C, which is the ratio of the charge at the conductors يعني Q أو Q star أو Q1 whichever. بس أكيد عم نحكي positive charge. نحن حكما بنعرف على واحد من الكوندكتورز it's a plus Q وعلى other equal to it بس opposite obligatory. وشو بقول التشارج of the capacitor is Q علما انه ال overall charge of the system of the capacitor is what plus Q minus Q يعني zero. بس لا it's charged by Q plus Q on one of them والتاني minus Q. So the ratio of the charge على conductors, okay, and the potential difference which has the symbol delta V أو V. نحن شو بنقول دلتا في هي V final minus V initial، اوكي، بس مثلا بقول 12 فولت مثلا potential difference معناتها على واحد بلس 12 وعلى الثاني شو زيرو، فالبوتنشال difference بيناتهم وات 12 فولت. So I say it's a 12 volt delta V 12 volt أو V equal 12 volt مثلا. Okay, so C is Q على V where V هو it's a delta V which is always نحن بنعرف الدلتا V can be positive or negative بس نحن C is دايما positive. This is always positive. C is always positive. Okay, positive implies the V أو delta V is always positive لأنه عارفين حكما ال Q هي ال charge of the capacitor يلي أنا عارفة على واحد من ال conductors it's a plus Q and the other it's what? It's minus Q. Okay, now ladies and gentlemen, this C اللي هو Q على V ال Q is in coulombs, ال V is in volt, C is in coulombs per volt أو farad. هاي الفراد unit للcapacitance which has the symbol capital F. Okay, now you have to know something that although C is defined as Q على V, yet it is independent of Q and V. كيف بتصير هاي؟ How does this happen? Okay, طيب ما أنا عم بقول هو definition Q على V بس لا حتعتمد على Q ولا حتعتمد على V. Remember what have we said at the beginning? We said any capacitor is characterized by its C وأنا I charge it, okay, charge it by Q1, Q2, Q3, okay, ما حتختلف السي. يعني انتوا لما بتعملوا you're building up a circuit, okay, ladies and gentlemen, and you need a capacitor in your circuit, you go to the electronic shop, okay, and you ask them I need a capacitor of so and so farad. اوكي، فاذا هذا كاركترستيك. هلا انتوا قد بتشرجوه قد ما بتشرجوه قديش والبوتنشال ديفرنس اكروس ات وات از ات، اوكي، بس السي is what is constant is characteristic of the capacitor. How does this happen? لأن if Q is increases مثلا شو ما كنتوا حاطين Q you've added up the Q يعني you've increased the charging, okay, what will happen automatically? You've increased it or you've decreased it. فإذا if Q is increased or decreased then V ما أنا I'm measuring the delta V with delta V will be dependent على ال E يلي establishedين لأن remember delta V what is it? It's minus integral of E dot dl. فأنا ال E اللي حتنخلق هون أوكي بناء عليها there will be V. بس ال E اللي it's created here it's due to the charge, it has something to do with the charge, okay, it has something to do with the charge. فإذا إذا غيرت ال Q ال E حتتغير معناتها أكيد شو ساعتها ال V حتتغير أو العكس. ما أنا كيف I established the charges هون by a volt a battery I connected it across the terminals of the conductor يعني على ال conductors, okay, الكوندكتورز يعني على الكوندكتورز of the capacitor. لما حطيت V بناء عليهم there will be charge بناء عليهم في electric field. فإذا if Q increases or decreases then V increases or decreases correspondingly such that the ratio is fixed. أو إذا قلنا بالعكس if V increases or decreases then Q established على الconductors will be increased or decreased correspondingly such that the ratio is fixed. Okay, هذه what we have to know about the capacitance of the capacitor. اوكي. طيب اذا ما بتعتمد على الكيو على الفي، بتعتمد على شو it will be clear that the capacitor it will be أو capacitance of the capacitor okay will be dependent على shape of its conductors وأشياء تانية هلا بنحكي فيها. So that's why what we have under this title kinds or forms of capacitors. There are three main forms of capacitors, each of which has its own expression of capacitance C. اوكي. في عنا اول فورم هو السمبل فورم اللي كتير مطروق. اوكي. the parallel plate capacitor، والتاني هو the spherical capacitor، والتالت هو the cylindrical capacitor. بدنا نلاحظ صبايا وشباب انه النيم او التايب للكاباسيتور will be dependent على شو؟ على shape of its conductors. يعني لاحظوا صبايا وشباب شو كنا عم نقول؟ the shape of the capacitor is any shape. okay any shape. هلا لا شو حنقول؟ depending على الشيب، هيدا اذا كان plate وهيدا plate وهن parallel to each other بيطلع معي the parallel plate capacitor. طيب هون إذا الكوندكتورز كانوا spherical و separated by from each other by an insulator ساعتها شو بيكون spherical capacitor. أو إذا كانوا cylinders و separated from each other by insulator ساعتها شو بنسميهم cylindrical capacitor. okay. هلا we have to learn about the expression for C for each type of this. I will do it in a second video. Okay, ladies and gentlemen. So here we are going to stop. Okay, وما بقى عم يوقف.